Okay. All right, so take off my little mask. All right, so in this video, I wanted to go over taking action, and we're going to talk about the first three, or chapters 3, 4, and 5. So just hit the high points, because I know you're totally capable of reading this. So chapter 3 is about implementing tasks that promote reasoning and problem solving. So in this section, I thought they did a nice job in comparing and contrasting task A and task B, which is on page 30. They talked about the Petoskey population and pay it forward. And you can see that in the whole pay it forward task, that it was a better task in that it really did promote some reasoning and some problem solving. It wasn't just to take a formula and use it type problem. So, perhaps after you do a pay it forward type of thing, then you would do some problems that were more like Petoskey's situation. But even then, you may want to have it be able to generate some more discussion with the students. So there's lower level demands in this first task. It talks about more the memorization of the formula. And you want to aim towards having higher level demands that give you procedures. Procedures are important, but they have to have a math connection to really make it, kind of stick. And in terms of higher level demands, you want to have them really be doing the math, not watching you do it, not listening to you talk about it, but actually doing it themselves. And the discussions that were raised in Pay It Forward with the kids trying to figure out the best formula to use, whether it be linear or exponential, those are very rich discussions, and that's what you want to have. So in terms of analyzing teaching and learning, the task they give is the geometry task. And that was kind of neat also, because these are fun problems for kids to do, especially if you have like cutouts and they can actually manipulate it. The more they can touch things and make the connections themselves, the more they'll enjoy doing the math and then making those connections. So they give you some good discussions there as well. And then you have the case of Stephen Taylor. So they go into more details with it. They give you a whole script that you can look over and you can compare and contrast between Miss Culver's class and Mr. Taylor's class. Okay, Mr. Taylor tends to kind of hop right in there and answer the questions for the kids. So that's not what you want to be always doing. Is there a time to do that? Yes, absolutely. But in terms of having, the kids discover things, that's much more exciting for them than writing down things by rote. So that's pretty much the overview of that first chapter that we had to read this week, chapter 3. And that was all about, let's go back. It's all about picking tasks that really promote some kind of reasoning and problem solving. So for example, in my class today, my calculus class, I had them try to figure out the product rule and the quotient rule, which are rules for taking derivatives. So instead of me just telling them what it is, I will eventually do that, but I'm going to have them try to do it through a discovery method. I don't want to have them be frustrated, but I want to have them be intrigued and have them want to know the answer. So that's why I'm choosing to do it that way. In chapter 4, it was the topic was build procedural fluency from conceptual understanding. And it states that right at the onset, effective teaching of mathematics builds fluency with procedures on a foundation of conceptual understanding so that students over time become skillful in using procedures flexibly as they solve contextual and mathematical problems. Okay, this flexibility is a really key point. And the more that the students kind of really work with doing the math, the more flexible they become. Their brain kind of, tends to expand a little bit, which is a huge thing. So in this example, they talked about, exponential growth again. And what I really liked was when they got to the discussion of prisms and cylinders and how much they will hold, because that's a fascinating discussion. When we do this in calculus, we do it as a maximization problem. So given a certain piece of paper, can you build that into a box that will maximize the volume. And the kids will always say, well, now what is the formula for volume again? And that's a tip-off that they never really owned that formula. It was just a procedure for them. They didn't realize that, oh yes, if I take a surface area and I keep building it upon itself, that's what actual volume is. So it is the area of the base times the height. I'm not memorizing that. I understand why that is the case. And I thought the two examples they give you on page 54 and 55, excuse me, those were very, very good. They were easy to do. They don't require supplies. And what's nice, in this time when you have kids on Zoom, for example, they can probably get a piece of paper that size and do some of this. And perhaps they can use popcorn with it. They can use something that's easy to measure. They can use, kind of, I guess, Skittles. You're going to have some issues with some spacing in there, but it's a really good example about what controls volume. And that will generate a lot of discussion. And you'll find that they have that a good visual of what you're doing and what volume is. And then on page 58, in fact, they give you a good volume problem and how you would think about that. It looks like a house with a slanty roof. How do you figure out that volume? If you had kids that did the volume problems with the different size paper, my guess is they do really well on that kind of conceptual and abstract analysis of volume, okay? Because they have in their head and they had at their fingertips an expression for creating this volume. Okay, so then they talked about developing an understanding of procedures. There are tons of formulas to use and they can always look them up. But if they don't understand what they mean, they're not as effective. And they have a great example in here about the case of Nicole Bartlone with the quadratic functions. Quadratic functions are very fun to deal with. They also come up in many levels of math at the high school level. So they show up clearly, they kind of peek in a little bit in Algebra 1. They are handled more in Algebra 2. They show up in your geometry classes, and then they reappear in pre-calc and in calculus. So by the time kids graduate from high school, they have seen quadratics many times. Does that mean they understand them? No, it does not. So sometimes you need to have, a more dedicated practice to it so that they really understand it the first time through and not hoping that when you reinforce it the next time they remember it. But I think a lot of the examples that they go through here about, finding the vertex, the axis of symmetry, zeros, you need a lot of hands-on with that. And I think in this section, they talked about, looking at problems and kind of grouping them and figuring out, okay, given that I have a lot of ways to solve a quadratic or to find the vertex, what's the most efficient way given a certain problem type? I think that concept in any level of math is very, very important because that will have kids realize there's not just one way to solve a problem. And sometimes the fun and the expansion of the thought process in solving a problem is the best part of it. Not necessarily getting it, to the quickest, not necessarily always memorizing one way to do it, but to kind of explore it and see, is there another way that I could have done this, that I could have thought through this problem, and what kind of additional insights would that give me? So that's important to generate in your kids. And it should make them a little bit excited about the whole math piece. Okay, chapter 5 is important because you're going to do your paper on chapter 5. So if you look in your syllabus, this is chapter 5 is posed purposeful questions. And the NCTM Principles to Action paper, I have us focus on this chapter 5. So let's just look at that. So it says students will read the Principles to Action Executive Summary on the NCTM website. Students will focus their reflection on the 8 mathematical teaching practices on page 3 of the document. Students will view the video of the playground task and what else? And analyze this video clip and the transcripts. So both the video clip and the transcripts are at More For You at the NCTM website. So that's indicated in front of our book. I also posted the chalk and wire rubric for this. So let's just look at that. To have an exemplary paper, you want to do the following. Your paper has to include a very good summary of the complete description of each of the NCTM teaching practices and a personal reflection on each of the teaching practices. Okay, so that's to be exemplary, and that's what we're aiming for. Secondly, the analysis of the case study. So this is this case study about the chapter 5 work that we're going to go over in just a second. The analysis of the case study includes discussion of all related teaching practices, as well as discussion of how teaching practices not present in the case could possibly be incorporated into the lesson or future lessons. Okay, so you pretty much want to hit all 8 of these practices. Okay, and then lastly, the response meets course specifications for format, contains no grammar or spelling errors, and is organized in a logical and sequential manner. So that means read it out loud. Does it make sense to you? Have someone in your house read it. Does it make sense to them? Then you know you're on the right track. It's hard for you to edit things after you've been working with it a long time. So have someone else look at it for you, or reading it out loud sometimes really helps. Okay, so in terms of posing purposeful questions, there's some things to bear in mind. You know, do the question types matter? And they absolutely do. So you don't always want to have, if you want to have a good discussion, you don't want to lead with questions that have only one answer. Okay, you want to have some open questions. You want to capture in your class how your students are thinking, because that's going to give you an idea. Are you being successful in how you're teaching? Are you encouraging some very good and thought-provoking, thinking processes in those students? It's also going to help if when they say how they're thinking, no matter what they say, you are supportive of that thought process. You can guide them along maybe a different path in the thought process, but you want to be supportive, because if they think that you believe in them, they'll be more willing to share their thought process with you, and that's only going to help you as a teacher. Once you kind of, make a totally unintended insulting remark towards somebody, the rest of the class is going to take note of that immediately, and they're going to be less inclined to want to share their thoughts, and their thinking process with you. And if you think about it, you would be also if you were in that situation. So just open questions, positive responses to their questions. You can always, kind of redirect things in a good way, and that's all fine. Okay, so they talked about, the purpose of questioning in general. So you use questioning to gather information. So that may be more like the facts of the matter. But then you have these open questions, and the reasons for them are, to do some probing thinking. Have them really think about this. By the time they get to your class, they've been in a lot of math classes, and they have learned a lot. So they have to kind of start putting things together. Making the mathematics visible. If you ask them to discuss certain mathematical structures, it's going to make it easier for them to make the connections. So that's more in the open question technique. Encourage reflection and justification. Okay, so you never want to have someone say, well, why do I think that? Oh, just because. And you don't want to say that either. Okay, you want to have a reason why you are going down the path you're going down. Maybe you were thinking about something you had just done, or a student had just done last period in science, and they come in and they're kind of in that same sciencey mind frame, and that gives them a door to another way to look at your problem. So you always want to kind of know where that is. Okay, what else do I want to talk about? So they give you 2 examples in this chapter. The whole missing function task, that is really, really good. I really like that. And again, it's back to quadratics, and quadratics are a big part of math classes in high school. Absolutely, it's a valuable, valuable skill. I thought they had a great connection between lines and the parabola, and that's a very valuable thing. So if you ever have to teach this, this is a very good thing to go back to. They also talked about questioning in general. You have assessing questions, which kind of is continuing the conversation, and then you have advancing questions, which is well, it's advancing the problem solving. Those are the questions that you ask, like in group work, and you walk away because you want to come back and see what they think about that. So advancing is leaving the kids to think about things. So you're going to affirm what they're thinking. You're going to listen to what they're saying as you are doing your assessing questions, and then you leave them with an advancing question to keep them going and maybe to like lead them down a little path so that they're going to be honing in on the correct answers. So I would encourage you to look at the whole quadratic comparing products. I thought that was very, very clever, and I'm interested in doing that myself at some point. The task at hand that we're going to discuss in our paper is going to be the building a new playground. So basically what happens is you give the students a task. Okay, the task is that a city planning commission is considering building a new playground, and they want this playground, so this is the one requirement, it has to be equidistant from the 2 elementary schools that they have on a grid. Now that's a very lifelike problem. That's not like an abstract thing that would never happen. There's a very likely chance that that's going to happen somewhere. So let's look at that and let's explore that. So the problem sometimes with these textbooks is you've got a great example, but it's coming in isolation. So what will have happened before this came? So clearly the kids, when you hear the teacher speaking, they have talked about midpoint formula. They've talked about slope. They know how to do coordinate pairs. So you have to kind of, do this at the right time. We're not seeing all the lead into this, what the students have done, what they understand, even how they put them in groups. Like we don't know, are they same level groups? Are they mixed level groups? Like what do they have going on there? It's a pretty small class, which also is a luxury. I think they said there's 16 kids in it. So let's take a second, and I believe I have this up, so we can, if I can share a screen, I can play this. So let's just make sure that this plays. So here's the video clip. Hopefully you're going to be able to hear this.
So, okay, how did you come up with 3 points? Okay, I think the midpoint. So where's the midpoint? Did you guys agree? Okay, so that's the midpoint. So that's how many points?
I'm going to stop for 1 second. So the whole idea is you have to, or the students have to report back 3 possible locations for this playground. Okay, that's the task that they've been given. And so she has them in groups. You can see that there are some things on the walls already. So they've gone over other things that have tied into this project. And you can see that it's probably going to be, it looks to me to be a geometry class, given the decorations in the back. Okay, so I will let her continue.
Does that make sense? 1. So where's the other points at? How did you draw a square? Where's your square at? So was your thinking the same way as her? So are those the only points?
Okay, so you can hear her asking assessing questions. She's trying to figure out their thought process, and then you're going to see how she's going to leave with an advancing question.
No, there could be more. Could you prove to me? I'm going to come back and see if you guys can prove to me that there could be more points. So tell me, did you guys find that midpoint formula? Okay, so how are you using that midpoint formula to make sense of this problem? So, where are your 3 points? Could you point to me? Turn your page 2 to there. So where are your 3 points?
Like really, the line
So what does that line mean? So I'm gonna come back to that. I want you to be able to tell me, what does that little line mean? And we talked about, are there more points? Did you come up with more points?
First I got the snow.
what does the slope help you determine?
Where, like, can it determine, like, if one of them is something like that?
So you're finding the slope. What does the slope help you determine?
It helps me determine where I'm gonna meet. That's what I'm thinking. What, not only what I think, at first I was thinking about finding the gym, even though to see how far I'm going to make. And then it got to thinking, like, I'm just trying to think of the slope.
Okay. So you're gonna have to tell me how you can use that slope. I'm gonna come back and ask you, how can you use that slope? But how did you construct that line? How do you construct that line? Is it a curved line, or how do you construct it? So did you come up with 3 points? Did you come up with more than 3 points? Can there be more than 3 points? Why?
Because if I don't know how to explain, but I know what I mean.
Is there a pattern that you notice if there's more than 3 points? Be ready to tell me about what pattern do you see. If there's more than 3 points, what can you tell me about the pattern of seeing those 3 points? How did you know how to draw your line?
Because perpendicular.
What do you mean perpendicular? What does it mean when it's perpendicular? Oh, so you're making some 90-degree angles. And so what do you know else about that perpendicular line?
If that's it, in the midpoint, no?
Oh, very good. So don't forget that when we come to our discussion, let's see. So why are there more than those?
Yes. Oh yeah, we said one. There's one. Yeah, one more.
So you're saying that how many points altogether do you see? 4 points, and that's all the points that you can
I
see.
think I see it.
So there's 7 points.
That's what I think. That's what I think.
Okay. So if I wanted to build, this just say, I wanted to build the playground like 10 miles away from. Yes. Could I do that? Could I do that? How would I do that? What if I wanted to, because I wanted people on the other side of town also, so could I build it so that it would be equal distance and it's 10 miles away? Oh, what? I heard something. You might want to talk to them about it. I'm coming back over here.
Okay, so I hope you were able to hear that. Let me just get out of sharing. So I think she does a very good job of encouraging them to keep thinking and also kind of do that advancing question. So she's going to come back. So they've been given a task, a secondary task, to continue on the new path that they're supposed to be thinking about. So I also thought this was a very good example. She does a good job listening. So she listens to what they're saying, and then she has to ask them some probing questions because they're not all able to say why the answer is what they think it is. So it's a very interesting example. And you can say that, she also refers to keep those thoughts in mind when we talk about this later. So clearly there's going to be a large group presentation, debrief, however she's going to handle it so that they all have a good takeaway. You can see around her, the kids are very involved in this task, okay? They are owning their material, they're working it out together, they're using good math, they're doing the math, so it's a good example. So I think that's a good thing to be able to write about, because I think you have things to look at. You can still suggest some things. This is a small snippet, so you can build around it. Notice that she doesn't just follow what they call the IRE, the initiate, response, evaluate. I mean, she doesn't want just one word answers. She wants to have a thought process going. So I thought that was key. So I'm hoping that you're enjoying this book. I think it's a very good book. And I think you now are kind of into it and you see how the principles come into play. If nothing else, it should make you reflect on your own teaching practices. Oh, and I should say, if you're not able to understand like all the conversation, because there's a lot of background noise there, the transcript for this is also up on the NCTM site. So go ahead and read through that. But since this is going to be a pretty big assignment, I would go ahead and start kind of outlining that now because we've read the chapter. Now, there's other pieces you're going to put in as we read more chapters because you're going to hit upon all 8 of the principles, but I think you can probably start on this now. So I hope this video helped. Thank you very much, and I'll see you in class on Zoom.